In this example, we have a stone being thrown vertically upward from the edge of a cliff with an initial velocity of 64 feet per second and a height of 32 feet above the ground. Okay, and then we're given a function that this stone follows. This is a position function, s of t equals negative 16t squared plus 64t plus 32. So let's just envision what's happening here, right? We have a cliff of some kind, and a stone is being thrown kind of off of it, like so, right? And then down it goes, hits the ground. In time, right, it would look something like this. This is a downward parabola, so it's going to start at, so now let's do it in time, and this is going to be height. So we start at 32 feet here, and it's thrown upward, and then eventually the height hits the ground at 0. So in time, it's the parabola. A lot of times we think that spatially the stone must be thrown in a parabola, and it would be, but that's a different parabola than this parabola that's formed in time. This can be thrown almost straight up and then go straight down and just barely miss the cliff, but in time it makes this perfect parabola. So we're studying this parabola in time. And what we'll do is a deep dive analysis of what happens with this stone. Let's start with part A. Determine the velocity of the stone after t seconds. Well, the velocity is simply the derivative of the position. So velocity of t is s prime of t. Okay, and we can use the power rule to see that that derivative is negative 32t plus 64. Part B asks, when does a stone reach its highest point? That happens when the velocity equals 0. When v of t equals 0. Why is that the case? Well, if you can imagine throwing a stone up, right, you throw it up with this initial velocity in the upward direction, and right about here, just for one instant, at the top of the curve, the velocity is 0 as it turns around. So we simply take our velocity and set it equal to 0 and solve for time. So we have 0 equals negative 32, 32t plus 64. Solving that for t gives us t equals 2 seconds. Okay, so after 2 seconds, this would be about 2 right here, this thing reaches its highest point. Part C asks, what is the height of the stone at its highest point? Okay, well for that, we go back to our position function. Oh, let's maybe scroll a little bit up. There we go. There's our position function. And we just compute s of 2 seconds. All right, well, that's no problem. We're just back to happy algebra land here. Negative 16 times 2 squared plus 64 times 2 plus 32. Turns out that comes to 96 feet. We're working in feet here. So there we go. On to part D. When does the stone strike the ground? Well, we do that when the position equals 0. So there's our position function again. Let's just write it in here. Right, here's our position function up here. So when it strikes the ground, the position is 0 because this is measured as feet off the ground. So we have 0 equals negative 16t squared plus 64t plus 32. Okay, and then we can solve that equation there. Well, again, we're back to algebra. But I tell you one thing, it's going to make it a lot easier here to factor out this negative 16. Because that leaves us with t squared minus 4t minus 2. And now we can just solve the part inside the parentheses, set that equal to 0. That negative 16 just divides off. For the inside part, we're going to need the quadratic formula. It doesn't factor. Here it is with x. We'll actually be using it as t though, but same idea. So this gives t equals, so negative b, so 4 plus or minus the square root of b squared, 16 minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a, which is 1, all over 2 times 1. Okay, so what do we really have here? 4 plus or minus, looks like the square root of 24 all over 2. Well, 24 is 4 times 6, so that 4 will come out as a 2. So 4 plus or minus 2 rad 6 all over 2. Finally, 2 plus or minus rad 6. Now, if we were to compute 2 minus rad 6, that would give us a negative, and we're not really interested in negative time in this case. So let's just keep the positive case. So 2 plus rad 6. And if we wanted a decimal approximation, that might be useful here too. So let's do that. That comes to about 4.45 seconds. 45 seconds. So we should label both of these. Okay, there we go. Okay, moving on to part E. With what velocity does the stone strike the ground? Well, recall from before that the velocity, v of t, in this case is negative 32t plus 64. Okay, that's from part A, I believe, in this case. So we essentially now want to know the velocity of 2 plus rad 6. We want to know the velocity at that time. Okay, no problem. Negative 32 times 2 plus rad 6 plus 64. Well, that comes to, let's see, that negative 32 times 2 is 64, so those would cancel out. So negative 32 rad 6. And the units on that velocity are feet per second. So feet per second. There we go. And if you want an approximation, you can compute this out. It comes to negative 78.38 about feet per second. Let's just do that. Okay, there we go. And lastly, we have part F. On what intervals is the speed increasing? Well, the speed is increasing when the velocity and acceleration have the same sign. So let's take a look at this example again. If you recall, we have a stone being thrown from a cliff, and we're doing this in time here. It looks something like so. It hits a maximum height at 2, and then this is the time axis here. This is height, or we can call this s of t here, the y-axis. Okay, so maxes out at 2, hits the ground at 2 plus rad 6 seconds, and the acceleration is always negative in this case. It's always going down. So we have this, we'll call it a force, even though we're not really doing physics here, but the force is in the negative direction. We'll call down the negative direction. And in this first part, the velocity goes up, and then right here the stone stops at 2 seconds. After 2 seconds, the velocity is negative because it's going down until it hits the ground at 2 plus rad 6 seconds. So right here in this region, going up, v is positive, and then all the rest of the time v is negative. Well, acceleration is always negative, so velocity and acceleration match on the interval 2 to 2 plus rad 6. And then here either would work. You could do a soft parenthesis or a hard bracket for this right endpoint, though on the left one it has to be a soft bracket because we don't want to include 2 because there the velocity is 0. So the speed, there's no speed at all right there. So we'll leave it as soft parentheses on both, but certainly a hard bracket on the right side would also be acceptable.